Okay, in this video, we're going to evaluate trig functions using the unit circle as our reference guide. So before we start, I just want to mention a few things just to kind of know when we're looking up on the unit circle what they are. Okay, if you notice the unit circle has our reference angles, it has all the angles listed. And if you notice that each angle has got a point by it, right? An x and a y value, a point on the unit circle. Okay, just a little reminder of what these points represent. Back when we learned cosine and sine and tangent, at the very beginning, we did learn that sine represented opposite over hypotenuse. If we were looking at the right triangles, sorry, that's messy, hypotenuse, and cosine was adjacent over hypotenuse. Okay, that's the cosine. Okay, so let's just kind of show you what this is. Let's look at pi over 6. There's pi over 6. Okay, let's make a right triangle right there. And of course, my angle right there. Here's my triangle. My angle is pi over 6. Okay, so when we were doing with sine and cosine, if we look at this right triangle, right, we have the this side right here represents x, right? And then the height right here represents y. And then, of course, the hypotenuse is the radius, right? Well, the radius of a unit circle is 1. That's why we call it the unit circle. It's 1 unit. So our hypotenuse is going to be 1 each time. Okay? So if we looked at this, for pi over 6, if I said the sine, my opposite would be y. My hypotenuse would be my r, which is 1. So sine equals y. Likewise, cosine of pi over 6, the adjacent is x over the hypotenuse, which is 1. So sine equals y and cosine equals x. So if you were to look at any point right here, the x value actually represents the cosine and the y value represents the sine. Remember, every point on the graph is an x and a y, right? Just remember, for each point on this unit circle, the x value, the first one, is represented by cosine, and the second is sine. Okay, that'll really help. Okay, because when I give you an answer, like if I asked you, oh, what's the sine of pi over 6? You can come to the unit circle, look at the point right here, right at pi over 6. The sine is represented by the y value, the second one. So you know that the sine of pi over 6 is 1/2. The cosine is square root of 3 over 2. And then we'll move from there. Okay, so I hope that helps. This is how we're going to reference the unit circle when we're looking things up. Okay, so here we are. Let's dive in. Let's start with number 1, the cosine of pi over 4. So using the unit circle, let's go find pi over 4, which is right here. And they're asking for the cosine. Remember, for each of the points, the first one represents cosine, the second is sine. So the cosine of pi over 4 is the square root of 2 over 2. So let's write square root of 2 over 2. And that's my answer. Okay, I'm going to zoom in just a little bit to make it a little bit better to see. Okay, let's look at number 2, the sine of 4 pi over 3. So in the unit circle, let's find 4 pi over 3. So with all the angles, you can look it up. But remember, here we have it right here, 4 pi over 3. The third quadrant, which this is, let's see, first quadrant, second, third, and fourth. Okay, those are your 4 quadrants. Third quadrant angles, the numerator is 1 more than the denominator. So you have 4 pi over 3 or 5 pi over 4, 7 pi over 6. That's how you know it's a third quadrant angle. So it helps you look it up easier. So we have 4 pi over 3, and they're asking for the sine. So here we have the point. Remember, cosine comes first, sine comes second. So the sine of 4 pi over 3 is negative square root of 3 over 2. Okay, I hope that makes sense. Pretty nice and easy to look it up. Okay, let's look. Let's see. Let me zoom out just a little bit and let's look at tangent. All right, tangent of 7 pi over 6. So let's find the 7 pi over 6. All right, once again, it's one larger in the numerator than the denominator, 7 pi over 6. So we have it right here, 7 pi over 6. If you notice my 2 points, cosine comes first and sine comes second. Okay, so let's look at it. Remember the definition of tangent is sine over cosine. Okay, so our points only give us the sine and cosine. So we know that the sine of 7 pi over 6 would be -1/2. So I'll write it right here. Divided by the cosine, which is -√3 over 2. Okay, we just need to figure this out. So let's look. We have that. If you're dividing, remember you turn it into a multiplication and you flip the reciprocal. Here we go. The 2's cross out. And the negatives do too. We're left with 1 over the square root of 3. Okay, and that's the tangent. But now, especially in Pearson, they are going to want you to write your answer in terms of a rationalized denominator, which means they do not want to have square root of 3 in the denominator. So remember how we rationalize. Just to get to write it in a different form, you just want to take that denominator and multiply the top and the bottom by it. That will give you 1 times the square root of 3, square root of 3. And then the square root of 3 times square root of 3 is the square root of 9, which is 3. So this is the form that they're going to want you to write your answer. So the tangent of 7 pi over 6 is the square root of 3 over 3. Okay, one last one, this cosine of pi. So let me write it right here. The cosine of pi. How do we find that? Okay, let's find pi. Remember, pi is just half of the circle. So here's pi. Okay, and the point is -1 and 0. That's cosine and sine. So I'm asking for the cosine of pi. The cosine of pi would be, what, -1? And that's it. Okay, I hope that's making sense. Just find your angle and look up your sine and cosine and see what you can do with that. Okay, now for number 5. Let's find the secant of pi over 2. Okay, so now when we get to the parts where they're asking for either secant, cosecant, or cotangent, remember we have to work in terms of our reciprocals. Okay, we know that secant is the same thing as the reciprocal, of cosine, secant and cosine. So the way we'll do this is we want to first find the cosine, right, of pi over 2. Once we get that, then we know since they're reciprocals, then we can just flip the answer. So let's find the cosine of pi over 2, right? And then we're going to flip. Okay, so cosine of pi over 2. Come over here. Let's find pi over 2. All right, and we have the point is 0, 1. Remember, cosine comes first, sine comes second. So the cosine of pi over 2 is 0. All right, so we have cosine of pi over 2 is 0, 0 over 1. If we're going to flip it, right, flip, that would give us 1 over 0. Okay, 1 over 0, the 0 is in the denominator, that is undefined. So my answer is undefined. All right, that's what the secant is. I'd be careful on that because a lot of people I've seen in the past, when they get 0 and you flip it, you just want to write it as 0 also. But remember, 1 over 0 makes no sense. It's undefined. Okay, let's look at cosecant of 5 pi over 3. Okay, once again, let's find the reciprocal first. So we're first going to find the reciprocal of cosecant is sine. So let's find the sine of 5 pi over 3. Okay, so let's find that first, then flip. All right. Let's see. Okay, 5 pi over 3. Let's find it over here. Here's 5 pi over 3 in quadrant 4. All right, and my points are we have cosine and sine. So what are we looking for? We're looking for the sine. Sine of 5 pi over 3 is negative square root of 3 over 2. I'll write it right below. Okay. So now let's flip it. If we flip it, we get negative 2 over square root of 3. Okay, and that's what the cosecant is. But remember, Pearson is not going to want us to write our answer with a square root in the denominator, so we have to rationalize. All you do is you take that square root and you multiply the top and the bottom by that. That gives you negative 2 square root of 3. And remember the bottom, just when you multiply 2 square roots, that just gives you the number. All right? So that is the right way to write it. It's the same thing as negative 2 over square root of 3, written differently, but this is the way they're going to want you to write your answer. Okay, let's find the cotangent of 5 pi over 6. So we know that cotangent and tangent are reciprocals of each other. We also know that the tangent is defined as sine over cosine. So since cotangent and tangent are reciprocals, we know that the cotangent would just be reversed. That would be cosine, right, over sine. Okay, so I'm going to approach it that way. I'm looking for the cotangent of 5 pi over 6. Let's find 5 pi over 6, which would be quadrant 2. Okay, and remember our point, that's cosine and sine listed first. So our cotangent is cosine over sine, so let's figure it out. Our cosine would be negative square root of 3 over 2, and our sine would be 1/2. Now we just need to simplify this. When we're dividing, we can cross out our common denominators there, and we get negative square root of 3 over 1, right? And that's cotangent. We've already flipped it, right? We flipped it before we actually filled the numbers in. So it looks like my answer is negative square root of 3. Okay, and for our last two, let's look at the tangent of 7 pi over 4. Let's see. Let's find 7 pi over 4. That looks like that's quadrant 4. Right, and we know tangent is sine over cosine. Right? So in this case, remember cosine comes first and sine. So tangent sine over cosine. So that would be negative square root of 2 over 2. And then the cosine, that is, I circled it, but it's positive square root of 2 over 2. So those cross out, right, and give you, don't forget the negative though, that gives you negative 1. And that's our tangent. Okay, one more I wanted to show you is what happens when the angle you're given is larger than 360 degrees or 2 pi. What you need to do in that case is you need to find that coterminal angle. So let's take 17 pi over 4. Right? That's larger than one full rotation. So we want to subtract rotations, which in this case would be 2 pi, until we get an angle that's somewhere between 0 and 2 pi. So if we were to subtract 2 pi, let's get common denominators. So let's convert that. 2 pi, that's the same as 8 pi over 4. 17 pi minus 8 pi, that gives me 9 pi over 4. Okay, but that's still bigger because we know 2 pi would be 8 pi over 4. So let's take it one more time. 9 pi over 4, and we can subtract 2 pi, which is, once again, 8 pi over 4. 9 pi minus 8 pi gives me pi over 4. So we call this the coterminal angle. So the secant of 17 pi over 4 is the same thing as the secant of pi over 4. Because the angles are coterminal. Okay, so if we can find the secant of pi over 4, we know it's the exact same thing as the secant of 17 pi over 4. So let's look that up. Pi over 4, right here in quadrant 1, which is a reference angle. Right? We know we have cosine and sine, but we need to find the secant. Okay, so remember secant and cosine, right, are reciprocals. So let's find the cosine. Right, let's do that first, then flip. Okay, what's the cosine of pi over 4? Square root of 2 over 2. It's right there. Okay, now we need to flip it, and that would give us 2 over square root of 2. Okay, that's going to be our answer, but remember we have to write it as a rationalized number, so let's rationalize that real quick to get it in the right form. that gives me 2 square root of 2 over 2. And these 2's cross out. So my final answer is square root of 2. So that does require a little bit of algebra there. But using the unit circle to look it up saves you a lot of time. I hope this helps. This is, once again, the unit circle method.